Again, this is a series of webinars we're doing on security topics that are relevant today. The first one was on best practices for identity and access management, and had great participation and great feedback on that one. Today we're going to focus on application security, some of the current trends in the industry, some cool features within a product we use from IBM, and also some examples of what's going on in the common hacking scenarios and show you what that really looks like. So today we're going to have three folks help us with this webinar. We've got Jason Bellamy with IBM executive with Security Software Group. We've also got Tony Vera, who's a specialist with the AppScan product, and we have Pathmaker Group security specialist Riker Exum, who will also participate in the hacking demonstration. So please feel free to jot down your questions as we go through. We'll have some time at the end, hopefully, for questions, and then we'll close out with a special offer for those of y'all who may need some help with application security. So again, thank you for joining. And without further ado, we're going to get started with Jason, I believe, going through some topics here.
Hey, great. Hey, Keith, thanks so much. Can you guys hear me okay?
Yep.
Okay, super. Riker, why don't you just drive, just to make sure that it's easy here, and we'll just let you drive mine, and then we can pass it over to Tony. Does that sound good?
That sounds good.
Okay. Yeah. So Keith had mentioned. So my name is Jason Bellamy. I work for IBM. I'm in the security division, and I represent what's called an application security segment. So essentially, that's AppScan. And so I'm just going to go over a few things with you before we turn this over and show. Riker's going to show you some live hacking demonstrations. But I wanted to cover a couple of topics and trends and stuff that I see in the industry, and some things you might want to consider when you're looking at building your own practice. The first thing I'd like to do is just make sure we have a full understanding of what this is and what it isn't. So if you look at slide number 5 here, we look at the difference between static and dynamic analysis. So in application security, there is a third component that is essentially a manual review or architectural. So we're not going to be talking about that necessarily. In the scope of what we're talking about tools that help automate this function. And for those that hopefully you're familiar with it, but just in case you're not, I thought I'd just make sure up front that you understood the difference between static analysis and dynamic analysis. There is some confusion out there. There's a lot of terms for both of these types of testing, and so let me just go over that real quickly to make sure that we're all on the same page. So there's two components here. There's two different scans, really, and if you look at it, static analysis is also called white box testing. You'll hear it referred to as SAST or source code analysis. And essentially what this is a true scan. So we're literally doing taint analysis and pattern matching and code auditing, and we're looking at code. And so we can pinpoint areas in the code that look suspicious. Okay, so this is before an application's compiled and put out to production. Okay, so that's static analysis. Dynamic analysis, which hopefully you know, is essentially what we term it as a hacker in a box. So it's us throwing messages at essentially a running web application, and we try to exploit it. Okay. On the next slide, on slide number 6, when you look at the difference between the two, essentially the process is the same. So whether you're using a static tool or you're using a dynamic tool, both tools essentially they scan an application or they scan the source code, they analyze it, they give information back, so we identify where the issues are. And then we report that, and hopefully there's different ways you can take action on that, right, to go fix it and remediate the issues. So for the breadth of what we're talking about today, these are the two types of solutions that we're talking about. Okay. On slide number 7, what I thought I'd do is get into a little bit of the trends that we see in the industry. And if you look at slide number 8, we have X-Force Group, and that's our R&D arm for the security division. And every year, we get information back from them. This year, 2012, it was 47% of all the attacks were basically coming through web apps. This number, it bounces. It can go from 43, it can go from 44 to 50, but essentially it's in between. It's almost half of all of the issues are web app. And it's been that way for the last 5-6 years. And essentially what you see in the marketplace is that we've done such a great job of securing in the perimeter in our infrastructure that we've sort of herded all the bad people to the best way in. And the best way in, the easiest way in, is essentially through these web apps. And if you look at the next slide, this is also from X-Force on slide number 9. What X-Force will do, they'll do a sampling of the security incidents. And so you see the bubbles and you see the timelines, and the size of the bubble means the severity of the attack, and the color is attributed to what type of attack it is. And with the exception of maybe the banks and the DDoS attacks that we saw that really spiked, cross-site scripting, SQL injecting, those are the two heavy hitters here, and you can see that it's really not changing that much. And these are the easiest ways into companies. And unfortunately, SQL injection and cross-site scripting, I mean, candidly, if you were a hacker, that's a very trivial hack. It's a very simple hack to do. And so for me, like when I talk to customers, I just puzzled with this because I think it's an easy fix, and it's something that we can go address, and we could certainly move that number from 47% down to something that's more manageable. On slide 10, I just accumulated some of these stats that you'll see attributed to application security and web app vulnerabilities, and you can see the percentages are high. The main point here, the takeaway, is that web apps are vulnerable. It tends to be the pathway to hacks, and it's on the rise. As we take these apps and we move them from PCs and desktops to phones and tablets, it's just going to make the problem worse. And so I think that this problem is not going away. It's out there, and it's definitely a challenge for our customers. Okay, let me get into real quickly on challenges. So I've got 4 slides here, and I used to talk about some of these topics, and luckily there's a report that came out. It was Stan's report in December. And what they did, they went out and they asked 700 companies, and they asked them different questions about web application security. And they got it back and they presented the results. And so these 4 charts, they kind of help me tell the story from a data perspective. But I wanted to kind of walk you through some of these things, some of these trends in the industry. Okay, on slide number 13. So you see the people, who's responsible. So when asked who is responsible for application security, this is the response you get back from folks. So we can see that it's software development's in there at 35%. Some people are saying it's the CISO. Some people are saying it's the CIO or CTO or risk and compliance, lines of business. This chart, I did this for a bank up in Canada, and they were their eyes kind of darting around, and they were giggling because they agreed with this. This is one of the challenges with us in the application security space, is that we have, because the infrastructure team is not writing this code. They're not building these applications. They're not buying these applications. And this would look very different if we were talking about threat or even IEM or people, kind of the people in security section. We know who's responsible for those things. But in application security, what you'll find if you haven't already is that it's an opportunity for us to go work with multiple people to figure out really who is responsible, who's going to take ownership and take action here. And this tends to be one of our biggest challenges in this space, is finding out who actually owns this, who's going to pay for it, who's going to invest in the time and the processes. The next slide you'll see. So they went out and asked, okay, tell us about the challenges in implementing application security program. And this is the results of these. And essentially what you see here is it's basically saying that there's a mass confusion. There's confusion on what applications do we even have in production? Who's going to pay for this? Again, it goes back to the slide I just talked about. Lack of resources. Lack of resources and disconnect between security and development. There is a lot of finger pointing. Development says, hey, security is your problem in the infrastructure side and IT side, and then IT says, hey, look, you were the ones that built this stuff. Like you should fix it. And then once you identified, okay, yeah, I agree, I should fix it, then there's a lack of resources sometimes for even understanding how do we go fix this stuff. And this is where like a company like Pathmaker could come in and help out. I mean, these are the roadblocks that you face on a daily basis that we can overcome. We can help you get better at this. We can help you find those lines and paths of getting stuff fixed. We can help you find the resources and train them up. On the next slide, you'll see that I get asked a lot, what should I do? Like, where should I start? Should I start with a dynamic analysis or static analysis? Where should I start? And I really like this slide because it shows that really you need to do it all. You know, the reality is a static analysis scan is very different from a dynamic analysis scan. And, you know, penetration test, as we know, is just a third-party dynamic analysis test. So PathMaker is one that would be represented in the penetration test. But this is a layered approach for security that really we need to be doing both of these things, right? And it's not uncommon that we find that people are doing third-party tests or penetration tests or using a SaaS model while also doing things internally and working on their own practices for static and dynamic analysis. The next slide I show is just, I think this one was kind of interesting because, you know, when they asked what are the drivers behind your application security program, overwhelmingly the number came back as regulations was the main driver here. And for me, that's a little disappointing because I get it. Like, I know that we have to comply with these things, but I think it shows why 47% of all web application, you know, why all the attacks come through the web application is because we do this because we have to, and it doesn't show that we're not really invested in trying to fix the problem in a lot of cases. The good news is on the regulation side is that if you are facing regulations, you know, HIPAA, PCI, compliance, we can make this very easy for you. So we can come in and set it up to where the reports that you have to submit on a monthly, weekly, annually, quarterly basis, we can actually create those really easy. So we can run these scans and actually format them for you in the specific regulation that you have to comply with. So let me get into a couple benefits before I pass it over to Tony. So if you look at on slide number 19, what I want to communicate here is that, you know, when you look at security application testing, a lot of cases, most cases, it's the security team that's sort of charged with this. So they're the ones that are running the tests. They may not be fixing it, but it's certainly, they're the bottleneck. And when you think about the number of applications, the size of those applications, the frequency in which those applications change, that's a lot for this small team to deal with. You know, when you look at the size of this organization, you know, the security organization compared to the development organization, for instance, it's considerably smaller. And so the idea here is what we try to promote in the industry is that let's have a lot more people play in the sandbox. Right? If we can get more people involved, we can scan more often. We can take this curve and move it so that the security group is not necessarily the bottleneck, that we completely overwhelm this group and we have them try to do all the scanning themselves. And on slide 20, this slide, I was at dinner. I'm at Black Hat in Vegas right now. And I was at dinner with a customer last night, and we were talking about this. And he's on the infrastructure side, the IT side, and he's trying to implement a program. Everybody's behind it. Everybody's nodding their head, yes, we should do this. And he's having a hard time getting the business people to pony up the money, essentially. And so this is the kind of stuff that we can come in and help with. So PathMaker and IBM can come in and help you put together an ROI and business value. And if you look here, we took this data from the Rational team, essentially. And what we find is that if we say that a vulnerability is nothing more than a defect, and it really is, that's really what it is a defect. The cost of the defect, if I find it in coding, is essentially $80 versus $7,600 in production. So we can literally do scans on your apps, and we can start using these calculations. Well, what if we found this in the coding stage? So for instance, if we had 100 vulnerabilities in your apps, and we found them earlier, we'd essentially save you $760,000. Not to mention, you know, the cost of a breach. The average cost is $7.2 million, and then you've got all the regulations and reputation damage and all of that stuff on top of it. So the point here is that if you're out there and you're trying to put together a practice in your facility, we can come in and help you with this and help sell the idea to the software development group or the business folks that this is a good idea. A chart, I'm not going to cover this too much here, but on 21, this just shows you the difference when I talked about the security flaw as essentially the same thing as a defect. It is, but it's also a lot more costly, and so we like to use this to the development organization to explain, listen, it's not just your average functional flaw, right? The link didn't work. This is a totally different animal, and it's very, very costly. So
Jason,
yeah,
Jason,
go ahead.
if I could just jump in real quick to piggyback on that. For companies that are challenged with trying to ramp up a large program to do that testing themselves, obviously we're in a position to help augment that on a very regular basis. We've got long-term engagements where we come in just for a few days a month and we run through some cycles and give back the results, and then you go about your business. So it can be cost-effective even by using an outside service like us to do that.
Yeah, absolutely. Hey, thanks, Keith. So let me wrap up here on 22. I've seen this a lot more recently, and it's about governance. So what we're seeing is that a lot of companies, when they start implementing a program, one of the challenges is to find the people that could actually interpret what the results are. And so what we're seeing is we're setting up these what we call service bureaus, where we have a group of people that, from a centrally managed perspective, they can set the policies and procedures. They can set, if your company's just starting down this path, we can dial our filters back to where maybe we just scan for SQL injections, and we just say to our executives that we have scanned every application that goes out the door every time it's been changed for SQL injection, right? 100%. I can validate that we've done that, and I can actually put those filters in place centrally and push them out to the folks when they do the scans. Like if developers were doing the scans, they would have to run that scan. So there's some great validation, some reporting information. I can see which applications are at most risk. Is there a person over there that has propensity to keep putting these SQL injections into my code? And so having tools like this are really, really valuable from an enterprise management perspective. So with that, Tony, I'm going to turn it over to you.
Okay, thanks, Jason. And can you give me control?
Sure.
Okay, quick check here. Does everybody see this slide with the right-hand agenda item AppScan overview and demo?
Hey, not yet for me, Tony.
I saw the message come up saying I was the presenter, so I'm assuming.
Yeah, you've got the.
Did you share the app, Tony?
Yeah, that little menu didn't come up this time. It just came up and said I was the presenter. Where would I find the sharing?
On ours, when we got the Event Center, you can typically, under the Quick Start tab, you can do the drop-down for Share Application, and then you choose the application to share.
I don't have that like we had in the practice session. That it's not there. The little control center box is not there anymore.
I'll just try to assign you an extra privilege. Take a look real quick.
There we go.
I think we're getting some progress.
Yeah, there we go.
Okay, does everybody see the AppScan overview demo box?
Yep.
Okay, good. So I'm just going to talk briefly, now that Jason has kind of set the stage with some of the things that are going on out there in the industry as far as just trends and some of the challenges that companies are facing. I'm going to kind of drill down into some of the core capabilities we have at IBM around application security in terms of the products themselves. Now, obviously, many times these products, we sell those in conjunction with services, and we leverage partners like PathMaker to help our customers become successful with these products. So the slide that you're looking at right now is it just kind of shows some of the major components within the solution. The overall solution, we just simply call it the AppScan, application security solution, and it's made up of several components. And we kind of divide those into two classes. First, we have static analysis. So on the left-hand side, we see static analysis is, of course, all about source code analysis. We're trying to do a taint analysis to figure out where there are vulnerabilities within the actual source code itself. So we're scanning the code as opposed to a live website. The specific product that does this is AppScan Source. Then we have on the dynamic side of things, which is basically we're scanning the web application as it's executing. We're basically sending tampered HTTP requests and getting back responses and then determining where there are vulnerabilities in the application. We have two core products in that area. One's called AppScan Standard, and the other is called AppScan Enterprise. Standard is kind of like our desktop scanner, or as Jason said, a scanner in a box. Enterprise would be the dynamic scanner that, as the name implies, an enterprise-wide type of deployment would typically use that solution. Then we have some ancillary capabilities that are very unique in the market. These are differentiators for the IBM solution. One of those in the lower left here is runtime analysis. So this is the term we use for this is called glass box testing. And what we're doing is, even though we're doing dynamic analysis, which is typically thought of as black box analysis, we're actually doing something a little bit more, which is why we coined the term glass box testing. We actually download an instrumented agent to the web application server, and that agent is basically probing and inspecting the contents of that web application and then sending information back to AppScan Standard or AppScan Enterprise as it's executing the scans. It tells AppScan Standard or Enterprise important things such as perhaps that it found some new parameters that weren't discovered before, that we can then create vulnerability tests against those new parameters. So we tend to get more results. We find more problems than any other dynamic scanner can find as a result of glass box testing, and it also improves our accuracy rate. We also have a unique capability around the client-side analysis, and this is also part of our dynamic solution. So while we're running a scan, a dynamic scan, and in fact, while we're doing simply the crawl phase of a dynamic scan, the web application is very oftentimes sending back dynamic JavaScript. We have a capability in the tool that simply collects that JavaScript during the crawl phase, and at the conclusion of the crawl phase, it does a static analysis of that JavaScript to find static vulnerabilities, similar to what our white box testing tool is doing it, but it's doing it during the actual dynamic crawl phase. So a very interesting capability, and we actually ran a scan during development of this capability of the Fortune 500 companies and found that 25% of all the Fortune 5 companies had serious client-side JavaScript analysis problems. And then finally, we do have some hybrid capabilities, and this is really a result of AppScan Enterprise being able to do some very basic correlation between dynamic and static scanning. So those are kind of some of the key highlights of the AppScan solution. So this particular slide is somewhat of a methodology or a philosophy slide. It really reflects the belief at IBM that security testing is really not that different than normal functional testing in terms of we're trying to find flaws in the application, in the code, and we're finding that a lot of companies don't treat security testing the same way that they treat their normal functional testing. And more specifically, what we're finding is that many companies do their security testing at the very tail end, right before they go into production. So it happens like at the final QA phase, which is very late in the life cycle. And they don't really think a whole lot about security testing before that. So, Jason showed you some slides that, indicates just how expensive it is to find problems late in the life cycle. So the philosophy at IBM is that we really need to be treating security testing just the way we do functional testing these days, which is we need to be thinking about it throughout the entire SDLC. And actually, it should be thought of and considered right up in the requirements phase as well. We should be trying to figure out what our security requirements are going to be within the SDLC. So and we have tools, as you can see towards the bottom here, solutions in this space that help companies to do just that, to consider security testing early in the life cycle. our static scanning solution, AppScan Source, can be leveraged even during the coding phase. As we get major chunks of the system being coded, we can actually run security vulnerability tests on that code fairly early in the life cycle, hopefully saving us a lot of time and money because we're finding those problems early in the life cycle. So we also wanted to touch on a very important topic. More and more companies are coming to us saying, you know, we have an explosion of mobile devices that we need to support, that we need to build apps for. How do we manage security for those mobile devices, whether they be iPhones, tablets, what have you? So we've been looking at this problem for some years, and we kind of break the problem down into 3 areas. First, we have mobile web applications. This is a situation where we have an application, and let's just say it's an iPhone, and that application is really getting its functionality and doing its real work by communicating to the web application on a server. So that's one type of security and one way that we're going to deal with that I'm going to talk about in a minute, which is different than mobile native applications. So the little picture here shows Angry Birds. This is a classic native application where almost all the functionality of Angry Birds resides and runs directly on the mobile device itself. And then we have those hybrid applications where you're kind of doing a little of both. You're getting functionality that's executing natively on the phone, but you also have some of that functionality coming through communication to a web application server. So we needed to be able to address all 3 of these types of web application security. So we really broke that down according to the 2 classes of the solutions that we have, dynamic and static. So in order to deal with the web applications, so in other words, functionality running on a mobile device that's communicating to a web server for its functionality, we use our dynamic scanning tools. So what we're doing there simply is we use an agent that simply mimics the request header of a mobile device. So instead of being your typical, let's say, Internet Explorer on a PC, the header is going to be modified to mimic, let's say, an iPhone, so that when the web application server receives that request, it actually thinks it's talking to an iPhone device, and same with all the other web devices. Then for our the native applications, we needed to deploy our static solution to actually scan the source code itself. And we have support for 2 major platforms. We have support for Android, and now with our latest release, we also have full support for iOS. We put a huge investment in these capabilities and in these platforms. We analyzed over 30,000 of both the Android and the iOS APIs that needed to be marked up so that we could do a thorough analysis of those web applications. So obviously for Android, we're looking and scanning JavaScript and Java, and for iOS, we're scanning Objective-C. And we do have interoperability with the Xcode environment for those iOS developers. And with this latest release, we've also developed a native AppScan Source GUI that runs on the Mac. Okay, with this, I'm going to turn it over to Riker. He's going to talk about the OWASP Top 10, and then he's going to demonstrate a few live hacking demonstrations.
Thanks, Tony. So as you can see on this page here, Tony, you going to hand it back to me, or you going to?
I'll just go ahead and click through this.
Sure. So OWASP is an organization, if you're unfamiliar with it, that puts together a top 10 list of common vulnerabilities found on web applications, which is, you can just go to owasp.org and pull that up. And as you can see on this slide, there's a couple that are kind of the most common ones, which are injection flaws. Those are your SQL injection, LDAP injection, things interacting with a database, typically. Also, broken authentication and session management, essentially not properly guarding your tokens that are securing your actual access to that web application. And one of the other ones we plan to demo today is cross-site scripting vulnerabilities, where you can attack the end user, even potentially take over their browser or steal their authentication to choice sites, as well as there's quite a few other ones that are on there, which I encourage you, if you're not familiar with this list, to go through it in depth and definitely review it against your environment. Go ahead and go to the next slide. Right. So I'm going to go ahead and take control back over here. Bear with me just a moment. And so essentially for today's demo, I wanted to go through a couple different vulnerabilities that are on the OWASP top 10. They're ones that we'll occasionally, if not commonly, come across on the site that we'll do penetration tests for. And so for today, I wanted to go through cross-site scripting vulnerabilities, as well as the standard SQL injection attack. And I'm also going to kick it back over to Tony, where he'll show you actually an even more advanced attack that's quite interesting. So to start off, we're going to basically talk about this in the context of a financial institution application. And typically people that are interacting on the site have valuable assets behind the login, which include financial or personal information, things like that. So one thing that I look for as a penetration tester when I go on a website is I look for places I can type stuff in. Because if I can type things in, sometimes that allows me to either pass data to the user's browser or also to the back-end systems on the web application. Both are of great interest to me and make it a prime target for attack. So, for example, this particular site, the Altura Mutual site, it's got a search function, which a lot of websites do, and so you can just go in and you can type your name, for example, and if you click enter, it'll actually return your name, which is good to see because it's actually returning the value exactly as you put it in back to the user's browser. And so one other interesting thing as well, is it sanitizing the input? Is it allowing me to type in just, say, standard HTML code? So in this case, it allowed me to pass the ability to change the formatting of the text in standard HTML, which kind of tells me, one, it's not sanitizing user input, and it's accepting standard encoded characters. It's not trying to prevent attacks in some of the most recommended ways. So in this particular case, we'll try out maybe just a simple cross-site scripting attack. So we'll type in script, alert, and then the value, and close it out. And so the idea here is we're trying to pass JavaScript to the user browser to have it do something. In this case, I wanted to create a pop-up. As you can see, by committing this to that search function, it actually just generated a pop-up message, which could sometimes have interesting values within it. So let's do that again and try to get something that's a little bit more useful to me other than 1, 2, 3. And in this case, I'm going to try to see if it will provide the current user's cookie values. So if I click that and submit it, you can see on here that it's actually providing in this little pop-up box the session ID that the current user's under, as well as some additional user information that, depending on the way that the website was developed, sometimes this could be clear text passwords. Preferably and hopefully that's not actually the case, but in this case it's at least obfuscated. But the most valuable part is it at least gives me the session ID I might be able to reuse for an additional attack for bypassing authentication mechanisms on the website. Well, in this particular case, it really doesn't do me any good as an attacker to find my own cookie value. But maybe if there's somebody that I actually want to attack, say, John Smith or something like that, and I want to send him maybe a malicious email that has a URL in it, what I could do is I could take this URL that's provided at the top here and essentially I could take that URL and I can send it to him in an email. In this particular case, it looks a little funny, and if I was John Smith, I probably wouldn't click on that if I got an email. However, if I took it and I obfuscated it using a URL shortener, so in this case I went out and I went to one of the standard URL shorteners that's out there and I shortened that particular email out, you commit it, it actually results in the same effect. But again, in this case, it actually provides a pop-up, which is of little use to me as an attacker. But the beneficial side is it's actually possible to take this value and forward it onto a remote web server that I do have control over and dump it into the access logs for that server. So, for example, I'm going to take this code here, which is, give me just a second here. So there's, you can basically script an attack, which in this case I'm going to initiate a JavaScript that calls the website that I own, so for example pathmaker-group.com, and I'm going to append to that just some little notation saying that this is a cookie, and I'm going to actually append the value of the user's cookie to it. So one thing that's important, if you're sending a link off to a victim, you're going to need to encode that and append that to that URL you're sending to them. So what you actually end up in the end with is this URL here. So you'll see actually that we're trying to get them to go to the destination demo.testfire.net with some basic search functionality, but at the end of it has the appended malicious script. So what it actually ends up doing is you run this URL on a victim machine, it'll generate a access attempt to a server that I control that includes that session ID that I just showed you and additional user information that was tied to that cookie. And this is all basically automated. I can go through a spammer and basically drop in a malicious URL into a whatever kind of email it is to try to entice them to visit it, and it will go through, and anybody that clicks on it, I'll get one of these listings in my raw access logs on my web server. So as you can see, then I can take this large list and try to replay that against the target and potentially get some access in there, which is great. That tells me that the site's vulnerable and that coming back as a malicious user, I might be able to actually get into their bank account, wire some funds to me over in Romania or China, wherever I might be, and go on vacation that week. So, and then to show you, this is actually AppScan standard. And so within AppScan standard, we've already run a test against this website. And you'll actually see on here one of the actual vulnerabilities that it listed as a high is cross-site scripting. And if you drill down into it, you'll find that the parameter that we attacked, which is a search function, actually displays the fact that this is actually a vulnerability that is on your web application that you would need to address. So if you were actually going out and scanning your own web app, you'd find, if you found a result like this, it will come in here, you can actually see the issue information, it will display kind of what the issue is going to look like. So for example, it tested an alert for 1630. It'll give you a technical description of what the actual issue is. The nice thing about it also gives you some recommendations on what do you do with it once the issue is found. And it will give you the raw request response from the original style to the modified one that includes the attack. And this is all valuable information for your developers. It allows them to go back, replay the attack, and then figure out what needs to happen to actually close the issue. And so then to step into the next issue, let's go ahead and go back to the website real quick. And so also if I've got a buddy, say James Smith, that's got an account at Altera Mutual, and I know he's got a lot of money, and I'd like to get a hold of some of that, maybe what I should do is I should try to see if I can get into his account. And so one thing that we kind of find on occasion is data leakage. And what that basically means is James Smith, for example, has an account here. I could just try the username James Smith and see if it actually gives me any results. So I'll just type in some garbage for the password and submit it. And so the data leakage actually shows up when it says, but this username was not found. And that's bad. We want it to say this username or password was not found, because this is actually describing to me that, well, this is definitely not his. So let's go ahead and modify it. Let's try James S. Maybe he's using that one instead. Same result. Okay, well, that's definitely not it. So why don't we try J. Smith. We'll type in some junk again. You'll see actually the result changes. So to me as an attacker, I can then go out to some of my favorite tools like Burp Suite or Bruter or some of the other ones that are out there, and I can try to brute force this login using a dictionary I pulled off the internet. which Anonymous has provided me so many of lately. I appreciate them for that. To go back and actually try to break into the to this particular user's account. Well, what if my dictionary attack doesn't work? Well, that's where it actually the SQL injection part comes in. And so, if the actual query is not, or the actual user submission is not being properly sanitized, you might be able to pass commands directly back to the backend database, and malicious things can occur. So, in the user login example, you can, at the end of the username, you can put a tick, and that tells it that some SQL information or SQL query is coming, and then you can give it an always true statement, so 1 equals 1, and then you terminate the statement with a double dash, and then for the password, it doesn't really matter. You just type in some junk. And once you click login, what it's going to do is it's going to see J. Smith, but then it's saying, oh, well, there's actually a SQL query. Is this a true statement? And it's just going to actually completely disregard this password field altogether. It doesn't even read it. So when I click login, as you can see, I just bypass authentication. Now, not only am I into J. Smith's user account, I'm into everybody's accounts because I've got admin user rights. So delete, add, remove, whatever I want, I now have the ability to do as an admin. And so I've basically just owned the site. So it's important to note that this portion as well can actually be discovered if you're using AppScan. And so on here as well, you'll find a little drop down for SQL injection. Whenever you see this, you need to be obviously concerned. And for the login page, both the user ID and password fields are vulnerable to this attack. So I could put J. Smith in the username field, and then for the password, I can do junk information, tick, or 1 equals 1, and then terminate the actual query, and I can still get logged in as an admin. So again, you'll find some the issue information, maybe some code, maybe some screenshots that are included with AppScan standard, the actual full advisory, and then whatever recommendations that it makes, as well as the request response that's tied to it. So once it's done, you can come back in, if you know it's fixed, and you can close it, or you can, if you maybe test it and it's not actually vulnerable, you can close it out as well.
And Riker, this is Keith again, just to inject here, these two scenarios you just showed are still the two most common vulnerabilities and breach attacks out there today, right?
That's right, and SQL injection's dropping because people are finally starting to realize they need to sanitize user input, and sometimes actually what they're doing is they're making it more difficult to make the injection actually occur with some additional, I always have trouble saying that word, obfuscation of the actual code I'm trying to inject. Sometimes you can still bypass those security measures and still get the actual code to inject to the back end and still complete what you actually intended to do.
So even if you just targeted some testing against these two vulnerabilities, you would cut out potentially a majority of the vulnerabilities in a lot of people's sites.
The ones that will cost you a lot of money, you want to find these ones first, and you want to get rid of one of these as quickly as possible. Because if I can dump your backend database, or I can steal your user session for an admin or things like that, then I basically own your website or own that credential, and I can go in and do whatever I want. And they have quite a negative effect to the people that are actually attacked. So I want to go ahead and kick it over to Tony. He's going to do Tony, you ready for me to send it over to you?
Sure.
All right, and Tony's going to do an additional demo for us here.
Okay, is my desktop displaying?
Yes. Yep.
Okay. So what I'm going to do is I'm going to demonstrate a malicious file execution attack against Del Toro Mutual. And what this attack is about is we're basically trying to find a way to get malicious code uploaded to a web server, in this case, a banking website. And then we need to find a way to execute that malicious code in order to achieve some goal, to possibly steal data from the victim, corrupt data, whatever it might be. In this particular example, what I'm going to try to do is I'm trying to attack this banking application, and I also want to understand more about the network infrastructure of this banking application. So to do that, I'm going to try to inspect the contents of the Etsy host file on that remote server running this El Toro Mutual Banking application. Note the URL that you see on the screen there. That is a public URL. You can visit this fictitious website. It's one of the handful of websites you can legally hack without the FBI showing up at your front door. So in order to do a malicious file execution, again, I have two things I have to do. Get malicious code uploaded and then find a way to execute it. So one of the techniques that we use is to try to find a place on the website that accepts data from the user that then gets uploaded and stored on the actual application server. So I'm going to go ahead and just browse this website until I find a likely place where information is entered by the user and then stored into the application server. So I'm going to use this feedback form in the banking application and see what happens. So I'm just going to put in some garbage here and click the submit button. So I'm going to take note of a few things here. Number one, it did submit the data. It thanks me for giving comments, and it even remembered my name. It says that this data is going to be reviewed by customer service. So right away, that's a clue that the information I put in that comment field is likely being stored up on their server so that they can review it and get back to their customers. So this is good news for me as a hacker. The other thing I note is look at the URL that actually displayed this feedback, the thank you feedback. It's actually an executable URL, so it's comment.aspx, so it has ASP code inside of that. So that might offer me some possibilities as far as getting, if I can get the code uploaded, maybe I could tamper with this in order to execute my malicious code. So let's go ahead and run this again, but this time I'm going to go ahead and try to get some malicious code uploaded. Well, what malicious code? Well, I'm going to do something really simple. I have this little code fragment that you can see. It's simply some ASP code. It's 2 lines of code, and all it does is write out the contents of a file. And we can see that the file it's looking for is looking on a Windows system down in the Etsy directory where the host file normally lives. So I'm going to grab that code snippet and copy it. And then I'm going to use that code here in just a moment. So let's go ahead and put in some information. It doesn't relate what I put in for the name, email, test, and then junk in here for the comment. Now, before I click the submit button, what I want to do is intercept this particular request before it goes to the web server. And then I want to modify or tamper with the data that's inside of that request. So there's many, many tools out there for doing that. This one's just a little plug-in into Firefox called Tamper Data. And I'm going to go ahead and now that I'm ready to click the submit button, I'm going to go ahead and tell it to start tampering, meaning it's going to intercept any requests that go from the web browser to the server. So I click submit, tell it yes, I want to tamper, and now we can see some very interesting stuff. So the information that I'm really interested in working with is the post values. So we can recognize some of these post parameters from the form, right? So let me move this over here so you can correlate the information. Okay, so I'm going to skip this first field for a moment and come back to it. So we can see the name. It has the value Tony, just like we typed in. We have the email address right here, the subject, which was test, and then we can see the comment value, which I just typed in junk. And then the submit is nothing more than the submit button. Now, the other thing that's interesting here is that first field called C file. And you notice that the value is comments.txt. Well, that is likely telling me that whatever I put in the field for comments is going to get stored in this file called comments.txt. So this is good news for me because if my hunch is right, perhaps I could put some ASP code in the comment and have it stored inside of a file that resides on the server. In this case, it would be comments.txt, which is going to present a problem for me, but we're going to get past that. So let me go ahead and paste those 2 lines of ASP code that I copied, and we'll paste it into the comments field. So there's my malicious ASP code. Now I'm going to have to do something to this C file because a text file can't be executed, right? So even if I'm successful in uploading this ASP code to the comments.txt, I really have no way to execute it on that remote server. So what I'm going to try instead is I'm going to try to have it write this information to an ASPX file. So I want to type it to evil.aspx. Okay? So if everything is right and my hunch is right, this code will end up residing on the server in this particular file called evil.aspx. So I'll click OK, and we can see that the request was sent to the server, and it succeeded. We didn't get any error messages. I'm going to stop tampering for the moment. And now we come back to the web page, and again, this is good news because we didn't get any sort of errors or anything like that. You'll notice, just like before, the feedback message, the thank you message, was displayed as a result of execution of comment.aspx. So, if everything went well, my malicious code right now is sitting up on that server, the Altoro Mutual server, and there will be a file on that server called evil.aspx. So what I'm going to try to do is execute that by simply replacing comment with evil, and then hit return, and voila. So what's just happened is we've sent that URL to the server, and it executed exactly what we told it to, evil.aspx, which contained my ASP script, which then echoes out the contents of the host file that resides on that server. So I've achieved my goal. So if this were a real Etsy host file, I could now gain a lot of intelligence about the makeup of the network, what the IP addresses of various machines are in that network. But I want to emphasize that you could do anything you want in that ASP code, right? You could do quite a bit of damage with ASP code running on a remote server. And it doesn't have to just be ASP code. It could be JavaScript. It could be just a batch file that we write out and execute on the remote server. So anything that we can put in an executable, we could then go ahead and have it run on that remote server. So that's it for the live hacking sections here. Let me go to a PowerPoint slide here. What I'd like to do is open it up right now for Q&A. And we have just a few minutes, and then Keith's going to close out with kind of some next steps. If you have any questions, there should be a kind of raise your hand button on the right.
Yeah, on the participants control, if you'll click that, you'll see a hand, and you can raise your hand if you'd like to ask a question. Okay.
Hi, Charlie.
Hi. My question is will I be able to get a copy of your slides? I don't have technical right now enough to questions about that, but will I be able to get I saw it said you were recording this session, so
yeah, the webinar will be available for replay, so you'll be able to view it at any time.
Okay, great. Thank you.
Anyone else? Great. Well, I appreciate everyone joining today. And again, well, this is a series. The next topic will be regarding security intelligence. We do have an offer for anyone who's participating in the webinar and would like to have us get a little more involved in your environment. We will do a free scan of your web application. PathMaker and IBM will join forces to help with that, and we'll get the results back to you, and you can basically just do a double check. If you think you're doing a decent job but you want to have someone take a second look, we're happy to do that. If you just want to get started understanding more about what this technology can do, it can help you in that way as well. So be sure and contact, just reply back to the invite you got or talk to your representative who sent the invite, and we'll be happy to get with you on that. So thank you for joining. At this time, we'll close the webinar.